Right, a couple of these motion questions. So the first one, a particle P is moving along a straight line. The fixed point O lies on this line at time t seconds where t is greater than 0. That becomes important. The displacement s meters from P is given by this cubic function here. Find the displacement of P from O when P is instantaneously at rest. So if it's at rest, its velocity is 0. Give your answer in the form A over B, where A and B are integers. So we've got a position function here, which tells us for a particular time where we are, kind of where we're standing. If we differentiate that, we're going to get the rate of change of position with respect to time. And that's essentially distance over time, which is velocity. We need to find when we're at rest. So we find the velocity function and solve for 0. And that tells us when we're kind of standing still. So the first thing to do is differentiate this function here. And so it's not dy by dx, it's ds by dt. And that's going to give us 3t squared plus 10t minus 8. And we want to solve this. We want to find out when this velocity here is 0. So we do want to go ahead and set this 3t squared plus 10t minus 8 equals 0 and find out what the t is. Okay, this is important because in the next one I'm going to show you this is not what we want to do because we're not asked to find out when we're at rest, but we'll come to that later on. Okay, so we need to split this middle term and so it's minus 24, so I think that's plus 12 and minus 2, so 3t squared plus 12t minus 2t minus 8 is 0. Factor both sides, so that gives us 3t on the outside there, t plus 4. And then we're going to take a minus 2 out, and that gives us t plus 4. And so we've got 3t minus 2 times t plus 4 equals 0. So our solutions then are t equals 2 over 3 or t equals minus 4. Now we want to reject t equals minus 4 because we're told in the question t is greater than 0. So we can reject this. I'm going to put a line through that. And we now have the time at which we are instantaneously at rest, but we haven't got the displacement. This function here, we're asked for the displacement, find the displacement, it says. This function here, if you put the t in, it'll give you the s, and that's what we need, therefore, to do. So we're looking at 2/3 cubed plus 5 lots of 2/3 squared minus 8 lots of 2/3 plus 10. And you don't need to simplify this in any way. At this point you just put that straight into your calculator, and I seem to remember the answer comes out as something like 197 over 24. Let's do it. Move that somewhere. Come on, move. I don't know why I can't move that for some reason. I can. Right. Let's put it there. So we're looking at 2/3, but we want that cubed. Raised to the 3, and then we are adding 5 times 2/3 squared, and then what are we doing? We are subtracting 8 lots of 2/3, which is 16/3, and then we're adding 10, and it gives you this 7.185, but that button there gives you the answer. So that's your A and B, 194 was it, over 27. So the important thing to bear in mind here is that we are being asked to find out when the speed is 0, and that's why we do go ahead and solve this quadratic. First step is to find out what the velocity function is. That's the rate of change of position with respect to time. So we differentiate the position function, set it to equal 0, find the t, put the t back in order to find the s. This next question, you can go wrong with this question just because, let's just give ourselves a page, right? Because you do end up with a quadratic, and your instinct might be, oh, I've got a quadratic. Now, what I do is I set it to equal 0 and off I go and I solve it. But you'll go wrong if that's the case. So let's have a look. Particle P is moving along a straight line, just like before. The fixed point O lies on the line, just like before. Time t seconds, t is greater than 0, just like before. The displacement function is given by s equals some cubic. Find the minimum speed of P. Now, we are going to want to differentiate it. Let's just do that quickly, because that's going to give us the speed function. So again, ds by dt, and that's going to give us 3t squared minus 18t plus 33. But we've got to resist the temptation now just to set this equal to 0 and off we go. Because after all, if the velocity function ever does equal 0, then that is the minimum speed. You can't go less than 0. Okay, speed only is only a scalar, so there's no sense of direction. There's no minus speed. You can have minus velocity, but this is not what we're talking about here. So in fact, if you were to plot this function, this displacement function, you'll find that the speed never does hit 0. And that has quite interesting ramifications. So if you plot this speed function here, here's our axes. You get a quadratic. We can see it's got a positive coefficient of t squared. It looks like this. Now, normally when we set a quadratic equal to 0, we're finding out where it cuts the x-axis. But this doesn't cut at all. So if you go ahead and idly bung this into your calculator, you'll get an answer which has I in it, because this quadratic doesn't have any real roots. It doesn't equal 0 anywhere, and that's gonna fox you. We're being asked to find the minimum speed. So really, we want to find the t, which corresponds to this minimum point here, and then we're going to plug it back in and find the that's no longer s, that's v, because this is the velocity graph, and that will be our answer. So in fact, what we now need to do is differentiate this again, and then we're going to find the minimum point of this quadratic. This is one way of doing it. At least. So we've got our velocity function is ds by dt, and now we want to do dv by dt, and that's going to be the derivative of this function here, which is now 6t minus 18. I don't know why my iPad always downloads Turkish. I think it's, assumes that must be what I'm writing. Okay, so we are going to, now we do want to set this to be 0, 0, because it's the gradient. We want the point on this curve here where the gradient is 0, and that's at the bottom here. All right, so we do want to now solve 6t minus 18 equals 0, and that means that t equals 3. That gives us the time here, but we want the velocity. So we're going to put that into the speed function here, and we end up with 3 times 3 squared plus 18 times 3 plus 33, and that gives us, what is that, 27 plus 54, no, it's minus, let's just be careful about that. Oops, make my eraser a little bit smaller. That's a minus 18 here, so that gives us minus 54 minus 54 plus 33, and that gives us an answer of 60 minus 54 is 6. And so that is the speed here. This is 3. At time 3, we're going a velocity of 6. And everywhere else on this curve here, we're going faster than that. That is the minimum speed. And presumably it's in meters per second, but the mark scheme doesn't ask you for that. So this is your final answer. And just a quick recap, what we've done there is we've differentiated the position function to find the speed function, and then we've differentiated the speed function to find the gradient function of the speed, which we solve for 0 to find the point on the speed curve here, where the minimum is, where this turning point is, i.e. where the gradient of this is 0. So the derivative of position is speed or velocity. The derivative of velocity is actually acceleration, but that's not the issue. That's not what we need to think about. We just need to see the point at which the gradient is 0. Another way of doing it, you could actually write this in completed square form instead. So we'll take this function and we'll write it in completed square form, and you'll see that the answer just kind of falls out at this point. So we are going to factor out a 3. That gives us t squared minus 6t plus 33. And then this bit in the middle we write in completed square form. So we've got 3 somethings, and that's going to give us t minus 3 all squared. Now we're going to get a plus 9 that we want to get rid of, so minus 9 plus 33, that's right, isn't it? And we can then get rid of the outer brackets. 3 t minus 3 squared, then this is minus 27, multiplying out the brackets, plus 33, which is 3 t minus 3 squared plus 6. Now, the important thing to look at here is that this expression here, or at least this thing that's being squared here, when you square something, you're going to end up with a positive value. It doesn't matter what t is. You've got a positive value or possibly 0, but you're never going to have a negative value. So we can immediately see, in fact, here, that if we were to make the left-hand side here, if we were to make this 0 by setting t equals 3, then we'd have 3 minus 3 squared times 3, doesn't matter, it's all 0. We've got plus 6. So we can see immediately here that the minimum speed is 6. It can't get any lower than 6. So I think at this point you could say something like, for t equals 3, speed is minimum at 6 meters per second. And that's obviously the same answer that we got there. The crucial thing about this question is that when you got this quadratic here, you don't just idly say, oh, right, it's a quadratic, I'll try and solve it. Because it's like this here, it doesn't have any real roots. It's not zero anywhere, so trying to solve for zero just isn't the point. So you've got to think about what the question is asking you. The minimum speed, if it were ever zero, then that is obviously the minimum speed. So you've got to take a minute to have a little think about it. So you could, if you were to look at one, you can always tell when a quadratic hasn't got any real roots like this. Obviously, you can plot it, and if it's kind of floating up in midair, never crosses the x-axis, then it doesn't have any real roots. Also, if you think about the quadratic formula, so what is it? Minus b plus or minus the square root of b squared minus 4ac all over 2a. Have a look at this thing. Let's do it carefully. This b squared minus 4ac. If that ever turns out to be negative, then we're taking the square root of a negative number, and we're immediately outside the realms of GCSE then, okay, because you're going to get a complex result. That's a result that has the little i's in it. So this value, b squared minus 4ac, is known as the discriminant. It kind of tells the difference, discriminates between a function that has real roots and a function that only has complex roots. So if b squared minus 4ac is less than 0, then you're not going to get any solutions for it. So you could, I suppose, kind of calculate what b squared minus 4ac is. Here's your a, here's your b minus 18, and here's your c. Immediately see that it hasn't got any real roots. But in fact, in the mark scheme, there's no mark for that. So there's no need to. So the important thing to bear in mind: find the velocity function. If you're going to do it by calculus, then find differentiate the velocity function to find the gradient function of velocity. You want where the gradient is 0 here. Find your t, substitute it back in to find your v, your speed. Alternatively, write it in completed square form. We're not solving it. We haven't gone any further than just writing it in completed square form. But that it's very easy at that point to eliminate essentially the left-hand side here, and find the t for which that is 0, and that gives you whatever this extra bit on the end is has got to be the